Okay. Fix this thing here. Anyway, so question is, why focus on African Americans? And the reason is, as compared to white Americans, African Americans are twice as likely to get Alzheimer's, 50% less likely to participate in biomedical research, and less likely to receive and seek treatment. And so our target goals with the African American community in Newark is focused on reducing Alzheimer's in the community, particularly locally, in expanding participation in research, and in increasing people getting treatment who do have dementia. Our program is called Pathways to Healthy Aging in African Americans. It's a university community collaboration. And since 2015, we've had over 800 older African Americans from the greater Newark area who've joined our program. And they joined for two reasons. One is to improve their own brain health and reduce their risk of dementia. And the other is to support research on healthy aging. Who is eligible to participate? Anyone who identifies as African American or Black, regardless of where they or their parents were born, age 60 or older, speak English fluently, willing to return every 2 years, and at the time of enrollment, cognitively healthy. The cohort that we've built up, this shows sort of a map of everyone in the East Orange, Newark area. You can see our university at the star. Almost half of our participants live in public and other federally subsidized housing. So half are, by definition, low income. This is a map of overlaid of our participants in Newark on a crime map of sort of violent crime. And you can see that although the university is a relatively crime-free area, many of our participants live in sort of the crime hot zones around Newark. Our education demographics range from 6 to in the 20s. About a third of our people have a high school or less. Some people have only elementary school, half have an associate's degree, and 11% have postgraduate. So very diverse educationally, heavily weighted towards the lower end of the educational spectrum. Almost 60% are pre-diabetic or diabetic, and we have very high rates of obesity. So a lot of the comorbidities that we see reported in the Black community, we see in our cohort. Now, let's talk about diversity. There is no cross-racial diversity in our cohort. Everybody is African American or Black. We don't do work comparing African Americans to other groups. It's all about looking at individual differences within the Black community. So our focus is on interracial diversity across a broad range of metrics. And there's a dirty little insider secret that those of you at the ADRC there probably know, which is that the small number of African Americans recruited into most ADRCs and pharmaceutical clinical trials tend to be those who are associated with the university medical system and tend to be highly educated and from the upper economic strata. And in fact, at some of the ADRCs, they report that their average African American participant is healthier than their average white participant because of this discrepancy in what strata from the socioeconomic and educational cohort they are drawing from. In our case, because we go directly to the community, we have a very diverse and representative sampling of interracial diversity in the Black community. How did all these people come to participate in our Rutgers Pathways study? We have an 18-year history of community partnerships. The first 9 years was just community engagement, public health lectures. And then in 2015, we built on that almost decade of community presence to begin to build the research program I'm going to tell you about. The most important message we have for community seniors is very simple, and that is a message that's perhaps best shared with you by our partners, the East Orange Senior Center Silver Steppers. They range in age from 80 to the early 90s. They perform at most of our community events. Most of them are participants in our study, and this is our view of what healthy aging should look like. So the message from the East Orange Senior Centers is that demographics is not destiny. To hell with the epidemiologists. We know something about the group, but each individual has the power to make changes in their life. And that's really our central message. We run Aging Smart programs as lunch and learns, primarily at churches and at public housing. And at these events, the most common question is, can we do anything to reduce our risk for Alzheimer's disease? And our answer is, yes, we can. And there are 6 steps that we describe: exercise regularly, challenge your brain, manage stress, get a good night's sleep, socialize with others, and eat a healthy diet. Now, some people will say, well, I have a memory problem. I can't remember 6 steps. But that's okay, because we give people a magnet for the refrigerator that reminds them every morning of those 6 steps. We also elaborate on these 6 steps in a publication that has more details that we share at all of our community events. We have a community brain health newsletter we launched this past year. It comes out 3 times a year. We print up about 5,000 copies. It's mailed to all of our participants, and it's distributed at senior centers and housing and throughout the city. It's how we have a broader impact and how we stay connected with our participants in the 2 years between when they come for our visits, with news they can use, recipes, brain healthy recipes, and testimonials from many of our participants. If anyone would like a copy of this, we also mail it out to our colleagues at other Alzheimer's centers, and we're happy to put you on our mailing list. Most of our cohort does not use Facebook, Instagram, or any of the social media. This is an old school crowd, and the old school crowd listens to the radio. And so here is Dolores Hammonds, one of our community brain health educators, using the radio to communicate.
We're here to teach them what they need to do. And exercising and eating correctly is one of the most important things that you can do. Sleep. We need to get sleep.
So throughout the radio is one of the ways we reach people. One of our long-term partners is the Newark Housing Authority. We work closely with Mayor Ross Baraka, with the leadership there. We show up at their events. We dance at their events. And it's one of our most important partnerships in the community. And it's one of the reasons why almost half our participants are from these low-income, federally subsidized housing.
This type of event is so necessary for all of us, because maybe one day we can put Alzheimer's behind us.
That's Glenda Wright. She spent about 30 years as a tenants advocate for low-income housing. She's our primary liaison to HUD, to the housing sites, and she does many of those programs there. Oops. We have monthly meeting. We don't have an advisory board. We have what we call a community stakeholders board, because everybody who comes isn't advising us. They're representing their interests. We have over 40 churches, 7 masjids, 13 public housing sites, and a wide number of other organizations that attend these events. Following our events, we always have a brain health salon luncheon. It's catered by the best Jewish deli in New Jersey, named Hobby's Deli of Newark. And you'll understand, given the food that we serve and the people who show up, why these are often known as our pastors and pastrami events. Our current participants are some of our best advocates for recruiting. A quarter of all new participants now come not by anything we do, but by word of mouth from other participants. So we asked some of our super spreaders, our brain health super spreaders, as we say, what do you tell your friends when you tell them about our program?
Give them the background of saying, this is something that's very prevalent in our community. Your mental health is important.
Men are a pain in the ass. They always have been, we always will be. We think we know everything and we think we're invulnerable. When we began our study, only about 7% of our participants were men. This obviously isn't going to cut it with NIH, who wants us to look at sex as a biological variable. So realizing how poorly we were doing recruiting men, we developed what I will describe now as a multimodal men's outreach strategy. As a result of that, we've gone from 7% to 25%. It's not yet where we want to be. We'd like to be up to about 35%, which is matches the local demographics, but it's a lot of progress. How did we do that? What would we do especially for men? So we have, as I said, a multimodal targeted outreach to older Black men. And by multimodal, I mean we do many things at once through different subsets of the community. We do special programming focusing on athletics and sports to target men's interests.
So we're having a classic car show and men's brain health fair combined for the first time here at Rutgers University-Newark. And the purpose is to reach out to men who traditionally don't come to health education events with local churches with their men's ministry.
So that's one approach that we do, an annual classic car show. We also work with the imams of the local mosques. A small fraction of the Black community are Muslims, but those are disproportionately men in the mosques, as opposed to the churches, which are often 85 or 90% are church. So we work closely with a dozen or so of the local mosques, and we host a post-Ramadan halal luncheon, which we'll do again in a month. We work closely with supporting post-incarceration reentry. A significant number of Black men are impacted by the criminal justice system. Every month, there are a number of older Black men who get released, sometimes after 20, 30, in one case, 50 years in prison. We work with a group there, a support group called the Returning Citizen Support Group. We help them with housing information, tech. Imagine, coming out after 30 years and being handed a smartphone and told, this is how you're going to have to organize your life. So we do tech support. We combine some of the returning citizens with our students to help them with smartphones. And we hired one of the returning citizens, Jerome Perkins, who's amazing, and he is our primary liaison the returning citizens, he brings us in the people who are coming in, each month who get released from prison, and sort of brings them into our group. We've recently begun working with a number of the Black college fraternity groups. There are 5 primary Black fraternities across the country. They all have affinity groups, and they're all sort of service mission oriented. And so it's another way to get a more diverse socioeconomic, diverse educational program. So all of this is only possible because we have a very dedicated community engagement team. You already met Glenda Wright, who directs all of our relationships with public and subsidized relations. Dolores Hammonds, we think of as our director of participant satisfaction and retention. She makes sure people are happy when they come through our study and stay happy for the 2 years. And Reverend Wilson oversees all of our faith-based reliance associations. Together, they bring almost 200 years of collective experience. They're supported by 5 other members of the community who work with them, assisting in various subsets of the community, such as Jerome Perkins, I mentioned before. And when we go out into the community with our community, our older members of the community, we usually pair them with some of the Rutgers students, many of who are public health students in other fields, so that the primary presentation is given by a member of the community, but the students who work in the lab are there to talk about the science or answer questions about the research studies. And we find that pairing of a student with a community member to be very powerful. Bottom line from all of this is that there's no quick, easy, or cheap way to recruit older African Americans to aging and brain health research. I have no nifty little tricks you can take home, but all the things I described are eminently replicable in Philadelphia, but they're not quick, easy, or cheap. So everyone who we've recruited, we call everyone a VIP, a very important participant. And what do these VIPs do during what we call the Rutgers Brain Check? Well, it's a 3-day affair. Day 1, they come to the medical school for saliva and blood tests. Day 2, cognition, health, fitness, and lifestyle assessments, about another 2.5 hours. On the 3rd day they come in, we do both MRI, brain imaging, and EEG measuring. And between days 2 and 3, many of the people do an optional 4 days of home EEG-based sleep monitoring because we're very interested in the role of sleep. They can earn up to $250, plus we pay them transportation for those 3 days. And we want them to return every 2 years or every 1 year once they reach 80. So what do we hope to learn from the participants who've joined? There are 4 key knowledge gaps that motivate our research. First, early detection. How can we detect the earliest preclinical and asymptomatic phase of Alzheimer's disease? How do genetics, environment, and modifiable lifestyle factors interact to determine who is most at risk or, importantly, most resilient to Alzheimer's disease? Personalized, low-cost, non-pharmacological interventions. We don't do drug trials, but we are interested in how different lifestyle changes will benefit which people in different degrees. And lastly, health disparities. How to ensure that all these advantages in early detection, risk and resilience, low-cost interventions benefit those most in need, especially African Americans. I'm going to start by telling you about early detection, and in particular, tell you about 2 tools, a cognitive tool and an imaging tool, an assessment tools that we've developed at Rutgers, which we find to be absolutely essential in all the research that we do. And they're also tools that might be useful at Penn through your ADRC. So our key finding number 1 is the Rutgers generalization tasks are markers of early cognitive decline years before dementia. So you folks all know that by the time someone is diagnosed with Alzheimer's, 80% of the brain damage has already occurred. The challenge is to come 15 or 20 years earlier, when it's just the beginning of the disease, which is when intervention is most likely and the brain is still largely intact. So here's our bottom line finding is we discovered that the earliest cognitive changes are not to memory loss, the canonical symptom of dementia, but rather the loss of the ability to flexibly apply, that is, to generalize learning from one situation to another. Now, let me explain what I mean by generalize. So generalization is the transfer of past learning to new situations. For example, if I try broccoli the first time and it makes me sick, I'm probably never going to have broccoli again. But what about cauliflower? Cauliflower is similar, but not exactly broccoli. What do I do? Do I eat it or do I avoid it? And that's the fundamental challenge of specificity and differentiation when it comes to transferring our knowledge from past experiences to something novel. Animal and human studies show that damage to the hippocampus impairs generalization of learning. That is, if you damage the hippocampus, you're not going to impair your ability to learn that broccoli makes you sick, but you will alter the tendency to how you're going to generalize that to other vegetables. Back in 1993, Catherine Myers and I developed a computational model of the hippocampus and its role in associative learning. I won't go into the details of this computational model, but I'll tell you the key idea. The key idea was that how new memories are represented by the hippocampus determines generalization. So I live in New York City now, and this is what my brain looks like. This is my view of the world. This is the way my hippocampus has warped the world to represent what's important to me. And what that means is that certain things that aren't so important to me to differentiate have similar representations, and I enhance generalization, which is why I think Indiana and Illinois and Idaho all like basketball. On the other hand, avenues in New York are very important to me. I separate those representations, so what I know about the restaurants and the real estate on one avenue won't generalize to the other. So the bottom line here is as we warp our representations of the world as captured by this New Yorker cover, that is going to have a functional consequence on how we generalize from learning. So similarity essentially determines generalization. Our computational model suggested that the encoding, this particular encoding schemes that I described, are dependent on the entorhinal cortex and the dentate gyrus. And that was where the representations are formed in the medial temporal lobe, and that's what's determining generalization. As distinct from the CA1, CA3 regions, which are functionally involved in the more traditional memory storage aspects of the hippocampus. Now, this sort of functional systems differentiation of the subregions of the medial temporal lobe are important for Alzheimer's because the time course of Alzheimer's starts out in the parahippocampal region in the entorhinal cortex at these very earliest stages. And over the course of time, it eventually transitions to the CA1, CA3, that is the brain regions responsible for the memory loss that is the most common symptom of diagnosed Alzheimer's disease. So what this all means is that we made the following prediction back in 1993, which is that early pre-symptomatic or preclinical AD may only affect representation and generalization of learning, but not episodic event memory storage. So what that means is that in this very early stage, where encoding and generalization may be impaired, current measures of memory, of episodic memory, and you're all familiar with these, mini-mental and the RAV-Vault and so forth, are not going to be picking up what happens at this preclinical stage, even though they are going to pick up what happens at a diagnosed stage of Alzheimer's when the CA1 and CA3 are being impacted. How do we test generalization? We take animal conditioning paradigms, which have been shown to be sensitive to the hippocampus and the entorhinal cortex, and we represent them as video games. So here's an example. Concurrent discrimination will show people a red octagon and a yellow octagon. We'll have them choose where they think the smiley face is. If they get correct, that's positive feedback. At a later time, there's a transfer generalization phase where they see something they've never seen before, but if they extracted the fundamental rule from the first phase, they'll be able to generalize, and that is make no errors or few errors in the generalization phase. Now, the task is actually more complicated. There are 4 shape rules where color is irrelevant, 4 color rules where shape is irrelevant, and in each case, the rule transfers from phase 1 to phase 2, but the irrelevant attributes differ. So this is a study we did with Moni De Leon and Steve Ferris at the ADRC at NYU back in the early 90s, where we had participants who had mild hippocampal atrophy. And what we showed is these people with mild hippocampal atrophy, not demented, cognitively healthy otherwise, they make, so we're looking here at HA as hippocampal atrophy, that's pink. We're looking at errors, so high is bad. So we see that there's very little difference in the errors in phase 1, but there's a huge difference in the errors in phase 2. The people with the hippocampal atrophy are basically starting over from scratch. Those with no atrophy show a tremendous amount of savings. In contrast, a delayed paragraph recall, a canonical episodic memory task, shows no difference, which is why, because of the graph on the right, these people are not determined to have dementia. So the bottom line here is that the real trigger, the real sort of signal for picking up what's happening at this very early stage of hippocampal atrophy are these phase 2 errors. And what that means is that learning is not affected at this phase, nor is memory, but rather generalization is what is being affected. So the key finding is that generalization tasks are new cognitive markers for detecting early cognitive decline towards future Alzheimer's disease, long before standard neuropsych measures of memory are able to detect any of these deficits. Which leads us to ask, what changes in the hippocampus and the rest of the medial temporal lobe during early stages of Alzheimer's so as to impair generalization? So what's going on? These people are not global amnestic. They're having very subtle changes in the hippocampus. Is there a way that we can measure it directly? So we do that using resting state functional MRI. So most of our participants who are able do an MRI. And what we do is a 10-minute resting state scan. So they start the scan, they're there for 10 minutes. They're not doing anything. They're just just still. And we take those 10 minutes where they're not doing anything and we divide it into 20 half-minute or 30-second slices. So we have 20 slices of their resting state activity while they're sitting doing nothing. Now, to explain the analysis that we do, for each slice, we do a graph theoretic network analysis to measure the strength of connections between key subregions in the medial temporal lobe. Now, to explain this metaphorically, let me shift for a moment. And what we ask is how rigid or dynamic are these graphs? So we're basically creating a network of connectivity in each half-minute slice. And then across the 10 minutes, we're asking how much are these networks changing across the 10 minutes? So a metaphor for this is to imagine two different parties and ask yourself, which would you, assuming you're reasonably extroverted, want to go to? So the first is a stimulating cocktail party throughout the evening. Small groups of people are coming together, chatting, breaking off and forming other groups and talking about other topics. Okay, that's one. So you might imagine these are the people at the beginning of the cocktail party. And throughout the evening, if you were to graph the social relationships, the conversations, they're changing. The groups are coming together and breaking off into different subgroups. Compare this with a really boring dinner party. And that's a fabulous representation of boring. If you look at the girl in the corner, she's sitting in the same small groups and everyone is talking to the same people all evening. So again, we start with the same network. And what we see is that at a boring dinner party, you're stuck talking to the same people all evening long. And so if we think of social connectivity as how many different groups do you talk with, then flexible social connectivity is this fun cocktail party. Rigid social connectivity is the boring dinner party. Now, all of this is really a metaphor for what we're measuring when we look at what we call dynamic medial temporal lobe connectivity. So rigid dynamic connectivity is associated with cognitive decline. That's where the different parts of the medial temporal lobe are connected strongly and consistently throughout the 10 minutes. Flexible dynamic connectivity in medial temporal lobe is what's associated with a healthy brain, better generalization, as you'll see later, and less risk of Alzheimer's, and that's where we all want to be, okay? So key finding number 2, medial temporal lobe dynamic network connectivity is an innovative neural network biomarker that we developed, which uses resting state fMRI to evaluate the dynamic changing connectivity of brain circuits in the medial temporal lobe, the very ones that are disrupted in early prodromal Alzheimer's. So those are really the two tools that we've developed, and they are relevant to everything else that we do and that I'm going to talk about here for the second half of the talk. Risk and resilience. How do genetics, environment, and modifiable lifestyle factors interact to determine who is most at risk and most resilient to Alzheimer's disease? Start talking about sleep. Main effect of self-reported sleep quality. If we look at people by their self-report, we see that the better the sleep quality they report, the higher the dynamic flexibility. So one evidence that this flexibility is associated, and we know from a lot of epidemiological studies that high quality sleep in general is associated with lower Alzheimer's risk, which leads us to ask, can quality sleep protect brain health in older African Americans who are at genetic risk? So now we're going to ask about the interaction between a lifestyle and a lifestyle protection and a genetic risk. So most people, when they talk about genetic risk for Alzheimer's, they talk about APOE. But that's not really a relevant genetic variation in African Americans. ABCA7 is, however. ABCA7 affects the transport of proteins associated with amyloid, especially amyloid clearance. There are 2 SNPs, and I'm going to talk about both of them here, but the most commonly known is called the ABCA780 SNP. It's specific to African Americans. The risk variant is not seen in those of European ancestry, and having that risk variant doubles their risk for Alzheimer's in African Americans. Epidemiologically, ABCA780 is more predictive of AD and risk in African Americans than APOE. We see that same distinction between APOE and ABCA7 that the epidemiologists see when we look at resting state medial temporal flexibility, that the ABCA7 status is far more predictive of changes in flexibility as opposed to APOE status, which doesn't really predict very much change. So let me describe here, we look at it, now we're taking this same gene, the ABCA780, we see overall associated with poorer cognition. So on the left, more errors, so poorer cognition in those who have high risk variant, lower medial temporal lobe flexibility in the high risk group on the right. So cognitively and neurally, we see this risk genotype being reflected in our 2 measures. But now what I want to do is I want to focus on each of them in turn and break that population apart based on their sleep quality. So let's look at the cognitive group. Pull them aside for the second. I'm going to take all of those people and I'm going to distribute them based on how they self-report sleep. And what you see is that the people with poor sleep, there's a huge effect of the gene. But in people with high quality sleep, the effect of the gene disappears. So it suggests that if you have this if you have the risk gene, if you have high quality sleep, you're not being negatively impacted by having the risk gene. So good quality self-reported sleep eliminates the generalization deficit associated with the high risk variant. Turning now to the medial temporal lobe flexibility, let's take that same graph, move it over to the left, and take all the people there and spread them out based on their sleep quality, and we see the same pattern, that the people with the poor sleep, with the risk variant, there's a huge effect of the risk variant in those who have poor sleep. If we look at the people with good quality sleep, the genetic difference disappears. So again, finding number 2 is good quality self-reported sleep eliminates the network deficit associated with ABCA7 high-risk variant. Finding number 3, which is still pilot, that good quality sleep mitigates the decline in RAVELD. So RAVELD is one of the memory tests. It's essentially, as it slowly declines, it brings us closer and closer to a diagnosis of MCI or AD. And what we see is that over 2 years, the low-risk people show essentially no decline. Those with the high risk, only those who have the poor sleep are showing a decline. Those with good sleep show little or no decline. So all 3 of these findings together suggest that high quality sleep is protective against the most important genetic risk factor for Alzheimer's in African Americans. So in summary, ABCA780 doubles the risk for Alzheimer's in older African Americans associated with poor cognitive and brain network health. Good quality self-reported sleep eliminates both the cognitive and the network effects of this. And preliminary data suggests that quality sleep also eliminates the cognitive decline in memory that you see over longitudinally in the risk carriers. The limitation here is all of this is self-reported sleep. It's only people's recollections of how well they sleep. Obviously, we can do better than that. And so a current direction with Bryce Mander at UC Irvine is to use multi-night home EEG sleep monitoring so we can identify the brain waves and the brain activities that are most predictive of cognitive, neural, and neuropathological measures of Alzheimer's risk. Sleep is a very complex phenomena across many phases, and we're particularly interested in non-REM sleep, slow wave sleep, and particularly sleep spindles that occur during slow wave sleep, which have been associated with clearance of amyloid in the brain. And in fact, the way we've done this in the past is we've used a headband, which is a 5 EEG sensors that people wear at night. This is what it looks like on a participant. And what we see is that sleep spindles, again, sleep spindles that have been associated in the past from REM, sleep spindles have no effect with RAVELD. So they don't correlate at all with standard measures of memory in our cohort. But if we switch to generalization, we see an incredibly strong relationship that the higher the sleep spindle density, the better people are doing at generalization. Again, sleep spindles do not correlate with structural integrity of the hippocampus. So these are MRI, structural MRI measures. If you look at sleep spindle density, here we're looking at left hippocampus volume. We see here no relationship between sleep spindle and structural measures of hippocampal function. But if we look at the medial temporal dynamic network flexibility from fMRI, we do see a very strong relationship that the higher the density of spindles during slow wave sleep, the more the flexible brain. And some pilot data suggesting that the more the sleep spindles you have, then the lower the levels of p-tau plasma markers. And we should have some more data on this in the next month or 2 from a much larger N. So in summary, from digital sleep, higher proportions of slow wave activity and greater density of spindle density during non-REM sleep is associated with reduced risk of Alzheimer's disease. These microarchitecture features of sleep may serve as markers of future Alzheimer's risk. And it suggests, therefore, that sleep might be a possible source of therapeutic target for modulating the risk for Alzheimer's disease, especially in African Americans with the ABCA7 risk variant. Another lifestyle factor particularly of interest in the aging and Alzheimer's world is fitness and exercise. This is from a slide from one of our exercise instructors. How do we measure physical fitness? We do a 6-minute walk. How far can participants walk in 6 minutes? This is an estimate of the VO2 max, maximal oxygen consumption. Once again, it does not correlate in our cohort with any of the standard measures of cognition, delayed recall, MMSE, digit span. So you might look at this and say, well, fitness doesn't do anything for quote unquote cognition. But if we look at generalization, what we see is that, in fact, there is a strong relationship in our cohort between high levels of physical fitness measured and generalization. But that's not true of everyone. And this is where we get back into understanding some of the complex interactions between genetics and lifestyle. Not everyone gets the same benefit from fitness. And we look now at another SNP. So there's the most commonly referred to ABCA7 SNP is the 80, but there's another SNP called 50, which is found in all races, both European and African. It's especially found in women. And it only increases directly the risk for Alzheimer's by about 20%. So in the standard epidemiological analyses, this is sort of an also mentioned. It's not really very important as a direct risk factor. But what we found is that indirect risk factor is very important. So that if we sort everybody by this indirect risk factor, ABCA750, what we see, and then we look at the fitness to generalization relationship, those with the risk genotype show essentially no relationship between fitness and generalization. The more fit they are has almost no effect on their generalization, their cognition. By having pulled all these people for whom there's no fitness generalization, the fitness to generalization relationship in those with the non-risk, of course, gets even stronger because we've eliminated the subset where the relationship doesn't hold. And there, in that population, we see a much, much stronger effect of fitness on generalization. So what this suggests then is that carriers of the non-risk variant show a strong correlation between fitness and generalization, but not on standard neuropsych tests of memory. But those with the risk variant show no significant advantage to being more physically fit. The implication is that this risk genotype may diminish the neuroprotective value of aerobic fitness, which leads to a natural question: does this gene also affect exercise? So what I was showing you were cross-sectional studies of fitness within a cohort, all measured at the same time. What if we go in and do an intervention? Will this affect in an individual how much benefit that individual gets from an exercise intervention? That is, can we help these people, those with low fitness and low generalization, improve? And that brings us to a topic of personalized, low-cost, non-pharmacological interventions. That is, cheap ways in which lifestyle changes can benefit people. So our method from a previous exercise study was a 5-month dance-based aerobic exercise program. Basically, it's a Zumba to Motown is the way we describe it. The first study was twice a week per session. It was held at local churches. And then, of course, we assessed people on all these measures before and after the intervention. For those of you at home who would like to get an understanding, I invite you all to stand up and take a 15-second cardio dance break and see what these classes look like. Here you go. So as predicted, after a 20-week aerobic exercise intervention, only carriers of the low-risk genotype showed related improvements. So here we're looking at generalization area, so high is bad. Nobody in the control group, that is a non-contact group that was sort of as normal, none of them showed any benefits. The exercise group, only those with the low-risk variant of ABCA750 showed a big change. Those with the high-risk variant, despite 20 weeks of twice-a-week exercise, showed no significant change in generalization errors. So really, you have to both do exercise and have the right gene to take the full benefit from it. Interim summary: older sedentary African Americans with the high-risk variant showed less cognitive benefit on this intervention than those with the low-risk genotype. The implication is that different people with different genetic variants may require different and personalized prescriptions of exercise to both improve cognition and reduce Alzheimer's. So how does exercise rewire our brain? Well, the result, we go back to our medial temporal flexibility. What we see is that those in the exercise intervention on the right showed improvements in medial temporal lobe flexibility, the graph on the right there. So that's where you want to be. You want to be increasing flexibility. And we see that after just 5 months. If we look at everybody and we look at the relationship between generalization and flexibility, I've argued that flexibility is sort of the underlying neural circuit marker for generalization. What you see is that there's overall the change in generalization from before to after correlates strongly with the change in flexibility from before to after. And if we separate all these people out, both the control people with the blue diamonds and the exercise intervention, there are 2 things to note. The first is that most of our exercise participants, the people in the orange, improved on both generalization and flexibility. That's good news. The scary is that many of our control participants, that is those in the diamond, declined over in 5 months. So the cost of being sedentary is apparent both cognitively and neurally in less than half a year. And that's something to take seriously for those of you who didn't do your cardio and exercise at the gym this morning before coming. So summary, exercise promotes medial temporal lobe flexibility and may prevent increases in synchronicity or rigidity across regions, protecting against cognitive decline. So our prescription is to get down and boogie, and this is one of the ways that we reward our participants by inviting them to our soul brain dance parties.
And make it a bunch of reference within our community and within our own family.
So now, of course, there was no control condition. So we have a new R01 that's doing a randomized clinical trial. We have a strength, balance, and stretching active control group. And one of the key issues is by now that we're looking at the plasma markers, we're asking a fundamental question about exercise. We all know exercise is good, but does exercise actually prevent or reverse the neuropathology, or the cognitive benefits only compensatory for an ongoing decline at a neural level? And that's generally an unanswered question. And we hope to get that answer from this. So the bottom line is, let me just summarize here. What do we know now about the interactions between genetics and lifestyle that we didn't know before the studies that we did? So genetics and lifestyles interact for brain health. Here's a big picture summary. So this is the big picture here. And there are two parts to this story. So the first is that we have a direct effect of ABCA780 on medial temporal flexibility and cognition and Alzheimer's, and that's modulated by a lifestyle factor, namely the quality of your sleep. That contrasts with ABCA750, where there's a direct effect of lifestyle, cardio exercise, which leads to fitness, and that's modified by a gene. So in one case, we have a lifestyle modifying a gene, and the other, we have a gene modifying a lifestyle intervention. So again, these complications. But what's critical in both cases is that we're measuring brain quality here in this group using this resting state MRI measure, and we're measuring cognition by generalization. All these effects disappear if we only were to look at structural effects or memory measures. So are we working on anything else? I don't really have much time, but here are two things. One is we're working with the University of Ibadan in Nigeria with the Yoruba people. Many African-American descendants of slaves are descended from people of the Yoruba. And so we're back in that Yoruba territory in West Africa, looking at some of these genetic issues in there. We're also very interested in the immunological bases of Alzheimer's, asking, do changes in immunological health across both innate and adaptive, particularly T-cell senescence, affect the risk and progression of Alzheimer's disease? And we have some preliminary data that I'll just skip past, linking genetics and immune function. We have a number of other projects, and I hope some of you, since you're all in Philadelphia for AAIC, come. We have about a dozen or so posters at AAIC describing a variety of the different research findings that we have here. So that's all until I see you again. I have 3 invitations for you. One is, as I mentioned, AAIC is in Philadelphia. You're probably all aware of that. In July, the day before AAIC, that is Saturday, July 27th, I'm taking over my parents' house out in Penn Valley near Gladwin. We're going to have a pool party and a buffet dinner. There'll be people from all over the world in the Alzheimer's research domain. And if any of you would like to come out and bring your family, send me an email. We're happy to have all of our ADRC Penn memory friends come out. 2 is we have a conference coming up in September, a U.S.-Israel conference. The goal is to expand collaboration between U.S. and Israeli scientists to help bring more Israeli graduate students to the U.S. for postdoctoral fellowships. We also have fully funded, thanks to our donors, fully funded student travel fellowships. The applications for that are due June 15th. So if there are any undergraduates or graduate students or even postbacks who are heading towards a PhD at the Penn Med Center or the ADRC, please have them go to this website and apply. And lastly, I've begun running as of last year. It's aging and brain health and Alzheimer's is phenomenally interdisciplinary. You go to AIC, and I don't understand 90% of the talks because I have only one PhD, but there are people from a dozen fields represented. So as of last year, I organized a conference, a ski conference, which is not so much a research conference as an educational tutorial conference. So we have 15-minute, broadly accessible short tutorials designed not only for the general public, but for people outside their area. Again, we have fully funded student travel fellowships, which your students are welcome to apply for. The general public is welcome. We didn't go all the way to Aspen to work all day, so the talks are all from 4 to 7 p.m., and we hold it at a resort that's right on the mountain. But it's limited to 50 people, and September 15th, we welcome people. We had a fabulous time. We had over a dozen tutorials last January. If anyone's interested in giving a very accessible tutorial to a wide field, we fine you if you use undefined acronyms or jargon. The idea is to be accessible. But if anybody would like to give one of these talks and come ski with us in a small, intimate meeting, find out more information at that website. So this is my website, and that brings me to the end. So I'm going to quit here, and I don't know how to stop sharing, but anyway, there we go. I'm done.
Well, thank you so much.
That was 45 minutes on the dot.
Perfect. We can open it up for questions. Probably the easiest way, if you just want to turn your camera on if you have a question, or use the raise hand feature. If you do either of those, we'll see that you have a question. And there is one in the chat. I'll give you a second to see that as well. But Morgan, you want to kick us off?
Yeah, absolutely. Hi, Mark. Thank you so much. This was amazing and very informative.
Thank you. And could I just ask people, since I am kind of sort of local to Philadelphia, and I'd love to get to know all of you. And by the way, you guys are only an hour and a half away on a Keystone Express or from an Amtrak, so you're all welcome to come up. So if you could just introduce who you are.
Yes. Absolutely. So my name is Morgan. I am an outreach coordinator here at the Penn Memory Center. And my primary focus is on our aging brain cohort dedicated to diversity study, which is looking at that disparity amongst Black and African Americans. I had the pleasure of actually connecting with you very briefly in St. Louis last fall. And so hearing this in depth again and further is amazing. I did have a question for you. We are in the midst of starting our participant advisory board. And so as we build this advisory board to create a connection between us and community members, I was wondering if you had any recommendations or suggestions on how to best leverage a participant advisory board to ensure that we are meeting the needs of community members while, serving and providing research opportunities.
So we used to have something we called an advisory board, and it was various people who came in, friends of this, friends of that. And like any sort of advisory board, 10% of the people did 90% of the work, and people would drift on and off. And so we shifted. We no longer have what we call an advisory board. We have what we call a stakeholders board. So every organization that we partner with, and so our meetings are kind of more like a Berkshire Hathaway kind of thing, where everyone who owns stock comes and represents it. So we don't have individuals on our advisory on our stakeholders board. We have organizations, church, mosque, public housing, and they then send. A church could send the pastor or a deacon. All of our partner organizations, like the Returning Citizens, they come. And so what we do is we have meetings once a month of anyone who comes, and not everyone can come every month. So we do it every month. All of that fabulous Newark pastrami and corned beef certainly helps bring people in, and allows them to interact with our students and everybody and all of our research partners at Rutgers. So that's been our main focus, as we shift away from advisory, but more think of it as stakeholders. And they come once a month, and they talk about the programs. They meet with our community engagement team, and it sort of evolved depending on who comes. Separately, we created this participant advocacy board, and we call it an advocacy board rather than advisory board, because we think of these are participants in our study. They may not be community leaders, they may not be ahead of anything, but they're in our study. And we tend to bring in people. We want to get them sort of represented from both public housing and private housing, from some of the different cities. And we mostly bring in the people who've been sort of brain health super spreaders. We keep track of who refers who. And so the people who are most enthusiastic are the ones who are referring their friends. And so they're here they come in for three reasons. One is so for us to help support them in doing this essentially viral, promoting for us. As I said, a quarter of all of our participants come through other participants, but they're also advising us, what can we do to bring value to our participants? Because we found that we haven't done as well with retention as we have with recruitment. So our retention does better than we expected. Our recruitment has gone better than expected. Our retention has gone less well than expected. So a lot of this is sort of getting feedback from them. What can we do to keep people engaged, to feel committed, to feel part of what we're doing over the 2 years? So 2 years later, we don't call them up and they say, well, who the hell are you? And I have no memory of ever coming. And the last thing we do is, as we spawn off a lot of, we have a lot of collaborations, we have a lot of pilot projects that are being spawned off. And so we use them as an advisory board before we would even consider going to the IRB. We ask the current participants, what do you think of this protocol? What do you think of these issues? So on and so forth. So it's almost like a community-based pre-IRB before we sort of pursue pilot studies.
Awesome. Thank you so much, Mark.
Yeah, and Morgan, if you're not on my email list, please email me. We'd be happy to have you come to any of our pastors and pastrami lunches, to our classic car show. And we often do, as I showed briefly, one of the things we do for our participants is we organize soul brain dance parties where everybody is expected to come in a 1960s or 1970s outfit. Many of our participants would only have to go to the back of their closet for that. And then we basically recreate a Soul Train TV show with a little bit of brain health advice in the middle. So come up.
That'd be awesome. I'll definitely reach out to connect.
Bring your bell bottoms and fringe and flowers in your hair and join us anytime. Yes.
And take pictures, please. Elizabeth, I think you had a comment in the chat.
You had a question about Elizabeth, why don't you just introduce yourself? Who are you and what do you do?
Sorry, there's like an announcement just as I'm muting over the mic that you may hear, but so my name is Elizabeth Espinal. I currently work with Dr. Mechanic Hamilton as a neuropsychology extern. I'm a PhD student at Drexel University in my 4th year. So my question was about your thoughts on the directionality between sleep quality and this sort of neuropsychological or clinical findings when it comes to cognitive performance, and whether it's the changes in the brain that are affecting the sleep quality, or if it's the reverse, where there's like environmental factors that impact sleep quality, and then thus there's this like trickle down effect.
So the answer is all of the above, our favorite SAT answer. Certainly, so African Americans on average get about an hour less sleep per night. And presumably that is mostly socio-environmental, high levels of noise, high levels of stress. For people who are younger, shift work that sort of shifts around. So there are many, socioeconomic indicators that are probably impacting sleep quality in African Americans. Any decline in sleep quality, whatever the reason, is going to affect your brain health. There's also evidence that the early stage of Alzheimer's may be affecting some of the sleep generation. We think that what's particularly important for spindles is spindles have been associated with clearance, with amyloid clearance. So whether it's the early stage of Alzheimer's that is, disrupting your sleep, or whether it's the fact that you're in a high crime, high risk, noisy, disrupted environment that's problematic, the end result is you're going to have fewer sleep spindles. And we think that is decreasing your ability to clear amyloid. And that's why we think it's compensating for the ABCA7 80 gene, because that gene has been associated with more rapid accumulation of amyloid. So potentially if you have high quality sleep, that's offsetting the accumulation, but that's all conjecture.
The work that I'm doing right now is looking at the coupling between hippocampal, sharp wave ripples, spindles, and slow oscillations, and the sort of quality of that coupling cycle. And so we can only study this in patients with epilepsy, but the correlation there is that they also experience a lot of clinical level memory complaints, and we also use the radial T and things like that to assess for that. And so looking at this sort of relation, the quality of the coupling of these oscillations as well, and in addition to other features such as like the density and stuff like that. So I was just curious.
Is this work with Mike Kahana and his group?
It's actually not work with Kahana. It's work with a lab that I collaborate with in New York. Dr. Mehta and Dr. Bickle are the 2 PIs for that at North Shore University Hospital.
Okay, well, it's hard to get to North Shore from Philadelphia without passing through Newark. So I invite you to come up and visit us in Newark anytime. So
great, thank you. Yeah.
And if you email me, I'll put you on our spam list for invitations to parties and meetings and so forth.
Great, thank you.
All right, Dr. Wolk, and then Andrew.
Hi, so I'm Dave Wolk. How are you doing, Mark? I direct our Alzheimer's Disease Research Center. And just a couple of things. One, I wanted to thank you for coming, and really enjoyed your talk, and really impressive the amount of work you've all built up over the years. It seems like it's been it's taken a lot of effort to kind of get to where you are now, and I think you all put in the effort to make it to that point. Two, I love to hear more about how you're recruiting male African American Black participants, because that is a group that we also struggle with in our study. And then three, I'll ask you the one really unfair question, which is, with ABCA7, you're seeing these differential effects, one with sleep and one with exercise. Do you care to speculate a little bit about what that gene does and why you might expect there to be this differential effect depending on the nature of the sort of healthy, salutary lifestyle factor?
Okay, so I'll try. So first question, thank you.
It wasn't a question, it was a statement.
I know, anyway, and I hope we'll get a chance to meet. As I said, I'm in the Philadelphia area one weekend a month, so I'd be delighted to come meet in person sometime out in the main line, Penn Valley, Gladwin area. Two, okay, now I said that, now I've sort of forgot. Three-part questions are memory screening in disguise. That's it. The second question was about men. Very early on, back in like 2015 or something, we had one of our big community events, and it was like almost all women. And I went to one of the ladies there and I said, well, where are all the men? And she looked at me and she rolled her eyes backward. She said, why should they come learn anything? They know it all already. I mean, I think we have, it's definitely resistant. It's not only Black men, it may be more extreme in Black men, but certainly all of us think we know more than we do and think we're stronger than we are. And so really our approach I've described, I mean, I think I pretty much covered all the various things that we're doing. I mean, we also have some church Saturday morning, church men. We've been working with the men's ministries. All churches have a men's ministry. Not all men's ministries are active. Sometimes they're sort of in name only, or they're pretty inactive. So we've been working with the church ministries, actually trying to help them build up and create a network of men's ministries, which is both strengthening their mission. And then we've done sort of breakfasts that are sort of, that there's a spiritual component that the church is involved in, and a health component that we're involved in. But I sort of described it, and I think the answer is underplay the education and health components, because those don't tend to attract men, and focus on other things that men affiliate with. And basically all your stereotypes about men are basically true. And we just have to tap into those and do many different things at once. It's not one thing, because there are many different men. The men who are in the Black fraternities are not the same men who are coming out of 20, 30-year prison sentences. So are not the ones necessarily, and then the churches, people often overlook the mosques. I think the mosques are a really good source, particularly for men. So a lot of outreach is, in the Black community is church-based, but we found the mosques to be a really fertile place for recruiting men. And the other thing is just be open to any idea. If it's a soul brain dance, but there's nothing that's too silly to not be worth trying once. So we do it all. But I think I pretty much told you all the things that we are. We do many, many things at once. And I think there's another message which gets back to my sort of bottom line, which was the title of the talk that Terrence saw, which was there's no quick, easy, or cheap way to do this, is that boots on the ground really matter. I have 15 people in my community engagement program. That's like a third of my lab. That's larger than most people's research labs, is just doing it. And a lot of it comes from our School of Public Health. I mean, the graduate students, the postdocs, but we have, as you saw, I think I showed you 8 members of the community who work with us. So, and it really is boots on the ground, because each person, particularly the community people, each of them, it's a lot of personal relationships, and only one person can only do so much. So I really think it's just a lot of boots on the ground. And each of these people not only is out there knocking on doors, going to places, but they all bring their own social capital. And not only the big leaders, sometimes they're just people who don't have a title, but they're just well-connected socially. And so I think it's that boots on the ground, a large number of people who are dedicated, who are out there doing recruitment, a little bit here and a little bit there, all adds up in the end.
Great. Thank you.
And the last question was about ABCA7. I don't know the answer. I will tell you 2 other things that we're doing with Fanny Elahi at the Mount Sinai ADRC. We're going to start to be looking at proteomics. So we're going to be comparing proteomics, and we're also talking with her and others about looking at iPSCs, induced pluripotent stem cells, to ask whether in a dish people can begin to ask questions about those who vary on the 80 variant or the 50 variant. So I'm going to basically punt on that question and say there are
That's
molecular
fair.
biologists who can answer that question, and I'm going to do everything I can to work with them and help them, but not try to speculate otherwise.
Okay, well, thank you so much. I know we had a couple of other questions, but we are over the hour mark here. And
Okay.
so if there are any more questions, perhaps we could compile some and
Yeah, just email me. I put my email address was in my last slide. It's really easy, gluck@rutgers.edu. I'm happy to connect you up. And Elizabeth, there's a graduate student in my lab named Peyton White, who's overseeing our sleep work, and I'd be delighted to just connect you guys up, and you can talk spindles and slow wave and till the night comes on. Anyone else who would like a copy of our newsletter, to be on our mailing list, to be invited to our dance parties, our lunches, and our occasional scientific activities, we welcome that. So
thank you again. I really appreciate your time.
Thank you.
Thank you, guys.
You have a great day.